I am now with Gender and Radiation Impact Project, and it is genderandradiation.org. Gender and Radiation Impact Project is a project, not a new organization, but it is a nonprofit, and we are very much of a startup looking for collaborative work. Very excited about the project I'm going to be sharing with you tonight. I was saying that I don't have advanced degrees. I started a career in biology, but before I went to graduate school, I myself had a radiation accident in a lab at Yale Medical School where I was a worker. And so I know that this presentation leads people to believe I might be an expert witness or that kind of thing. No, I'm not, but I'm an educator and an advocate. And last year, I did manage to get a peer-reviewed paper. It is this title, Disproportionate Impact of Radiation and Radiation Regulation. And you can find it on the genderandradiation.org website under resources. The URL says success stories. So we start with this amazing world and the fact that radiation and radioactivity are natural. Yes, they are. They're part of this world. However, we add to that natural background radiation with medical activities, with aviation when we fly high in the atmosphere, with efficient homes that don't let air flow through easily and the buildup of radon. And more than 2,000 detonations of nuclear weapons. This is taken from a short film. It doesn't show the fallout, it shows the ground zeros around our planet where nuclear weapons tests were done and the proportionate numbers of those tests. And then, of course, Hiroshima and Nagasaki, which we'll be talking more about. I want to apologize that I've indulged in several slides with text. I don't usually, but I want to make a few points for sure. And this is one. Ionizing radiation is energized particles and waves, and they affect our body at the cellular level. We know that at high levels, this can make immediate sickness and slow death in the form of too many cells killed. At lower levels, including natural radiation, background radiation, the outcomes may be delayed and are both cancer and non-cancer. We're going to go into that. We now have very solid papers showing that the risk from radiation for cancer from exposure is cumulative across our lifetimes. And that pre-birth in the uterus and in childhood, radiation is more potent than in adulthood. And yet I always want to add that our bodies have amazing repair mechanisms, and so not all radiation exposure results in harm. This map was constructed from the iodine exposures from the Nevada test site. At the top, it references milk drinking children. And this was put together clearly county by county, and the red areas are higher levels of dose and exposure. And clearly, this is something that affected a lot of people, and specifically children. This is a map of the reactors worldwide. It's somewhat out of date, but each red dot is a nuclear energy site. And these are the maps constructed soon after the Chernobyl reactor accident explosion. Arnie will be mad at me that I use the word accident. These aren't accidents. These are events that the engineers know will happen that makes them not an accident. On the left is Europe and the contamination of cesium. On the right is an incomplete map of the contamination in Japan. It doesn't include other areas outside of the immediate zone. And neither of these maps include aquatic contamination, which in the case of the Japanese coast and the Pacific is considerable. So radiation is invisible, but we can see the damage that it has done to these chromosomes. And in this picture, there are genetic material for 3 generations. The outline is the woman, then there's the developing fetus, and that developing fetus has cells that will become ova or spermatogonia, and therefore the genetic material for the next generation, the grandchildren, is present in this picture. So there's non-cancer impacts. I'm just going to run through this very fast, part of it so you can stop the tape and look at it later. But immune function, both reduced and stimulated, are results. Heart muscle damage, infertility, reduced fertility, given a pregnancy, spontaneous abortion, failure of the embryo or fetus, miscarriage later in the term, morphological and other defects which may or may not be heritable, and genetic damage to the next generation, to the ova, to the sperm in the developing fetus or child. And then there's the cancer impacts, all of them: leukemia, lymphoma, tumors, both benign and cancerous. And in pre-birth exposure, cancer can be triggered that results in childhood cancer and childhood leukemia. So this is a simple outline that shows that the energetic particle or wave hits the cell, damages genetic material, although I believe there are other consequences. Epigenetics is beginning to be identified. When the repair mechanisms do not work, a damaged cell may sit and wait and eventually be triggered. Maybe, maybe not. These are all events that we can't predict. We can't predict which exposure will lead to cancer. It is the perfect crime. In general, more radiation means more risk of cancer, but it's Dr. Caldicott's line that it takes only a single living cell and a single radioactive emission to potentially result in fatal cancer. So even doses too small to measure can be harmful. Now, biological sex is a factor in the outcome of radiation exposure. There are now global agencies that acknowledge this. Radiation is harmful to male bodies. Radiation is more harmful to female bodies. This difference is also influenced by age and is as much as a 10-fold difference. These findings are not yet reflected in official safety standards. Why does this matter? Because little girls are not protected by the current safety regulations of the world. And cancer and large things like heart problems have many causes. But when a percentage of those are attributed to radiation, we're underestimating. Radiation regulation based on reference man results in systematic underreporting of radiation harm for the global population. Now, I often end with this slide, but tonight I just had to bring it up sooner. This is a picture of health. These women stopped a nuclear waste dump coming to their ancestral lands. And you can see that they are healthy, that this is not only avoidance of harm, this is empowerment and joy. So what do we have today? In the United States, our primary regulator of commercial nuclear power is the Nuclear Regulatory Commission, and its regulations state, they say it. I have like 900 documents that say it's based on reference man. And that means that every individual who is being protected by the regulations is assumed to be a reference man. Here's the definition. He's 20 to 30 years old. He weighs 154 pounds. He's 5 feet 7 inches tall. He lives in a climate that's fairly temperate. He's white, and he has a Western European or North American habit or custom, which is part of why our colleagues in traditional lifestyles, Native American Indigenous people, other non-typical industrial society people, they are also not protected, even if they're the same size and shape as a reference man. How is this reference individual used? Well, I've already mentioned that they use it in calculations if they're evaluating exposure from a release or any other types. There's a couple exceptions we can go into, but not right now. In licensing, throughout all the licensing, reference man is used, and in risk assessment, driven by the reference individual. So when a risk is given as 1 in 100,000, they mean 1 reference man in 100,000 reference men. So I just want to, for a moment, reflect on the fact that there were big, huge workforces that did have some females, but they were mostly males, and they went into remote areas with fences and signs. And in that context, maybe reference man was appropriate. But this webinar is part of a new project to develop a new reference individual. We need a reference girl. All right. This is hard. We will have time to unfold all the reasons that we have only one big data set in the world that has all ages and both sexes, that's publicly accessible. But it's rooted in one of the most devastating and horrific acts that my government ever took, in my view. And I feel so awful about the bombing of Hiroshima and Nagasaki that to use the data from the survivors makes me cry every time I look at the report or the data directly. And every time I talk about it, I have to acknowledge that this is where the lifespan study comes from. It's from the survivors of that horrific act that happened in 1945. So many people have been influenced and impacted and lost in that decision and what came out of it. That all I can say is that I feel that it tarnishes my soul, and yet I have to continue because of the importance of the finding. It's not an excuse, but it's how I feel about it, that it's that important. So I did not collect the data. The data is all from the A-bomb survivors. It's from the lifespan study that was reported in 2006 by the National Academy of Sciences in a report called The Biological Effects of Ionizing Radiation, number 7, phase 2. And my own colleague, Diane Dorigo, who's on the call tonight, worked very, very hard to improve the panel that did this report. And much of the world's radiation regulation is based on the data that the NAS and the lifespan study have generated. And that is another reason that I use it, because everybody else uses it. So all of that said, we pretty much knew that radiation is more harmful to children, but there's a shock in the data that the NIS published. And I'm not the only person who looked at it. I'm not the first person who looked at it. Dr. Arjun Makhijani and his team at Institute for Energy and Environmental Research wrote a paper in 2006. I simply missed the memo. So in 2011, when I went and looked at this data, I was shocked because it's organized by the age that people were in 1945. They separated male and female. Those groups were tracked over the 60 years in the lifespan study, and cancers were counted, cancer incidence and cancer death. So boys grew up to be men that had cancer, not all of them, but some number of them. The girls who grew up, twice as many of them got cancer as the boys. And as a biologist, I will tell you that this is a stop the music moment when you have a result that's a doubling. And even when the exposure was to adults, there's a major difference. For every 2 men who died of cancer in the lifespan study, 3 women died. I'm going to take a moment to unfold this graph, and then I need a time check to figure out how much more time I have, because I erred. Molly, tell me how much more time I have.
Okay, you have, we can give you about 5 or 10 more minutes, and then hopefully have time for.
Good, I'm about there. That's perfect.
Okay.
So I just told you that age and biological sex have an influence on the outcome of radiation exposure. This flies in the face of everything that you'll hear from the regulators and from a lot of the literature in the nuclear industry, which is that they used to say it this way: a millirem is a millirem. Well, this slide, which is constructed by a colleague of mine, clearly shows that the pink line and the blue line are different. At the bottom is the age people were in 1945 when they were exposed. At the left side is increased risk of cancer from a single exposure. So this is where we've done some dicing and slicing and imagined for a moment that everybody got the same exposure, which they didn't. But when you have a big data set of 100,000 people, this is the kind of thing that epidemiologists do day in and day out. And so it's a what if everybody got the same dose? And that dose at 20 millisieverts is about the same as one CAT scan. So on this graph, females are pink, males are blue. You can see that the pink line is distinct and different the entire way across all the age groups. It never crosses. In every age group, females got more cancer than males. But the difference, as we started with, is biggest in the youngest children. On the left side, that's where that doubling is. I'm going to take for a moment and just look at the pink line. So the largest impacts are to the youngest females, but there's impacts all the way across. Now, the boys too suffer more than does the adult male. So I've put the reference man about where he belongs. When you do the math, I rounded up, other people round down, I round up, but not much, to say that the outcome for people who were exposed when they were little girls compared to that reference man is 10 times more cancer than was predicted. And as you can see, it's about a 1% increase, which doesn't seem like much, but it's a single exposure. And when you have the whole global population, 1% of the global population, as we see from the pandemic, is a lot of people. So little boys, about 5 times higher than predicted. But the regulator only sees that reference man point on the graph. Females are invisible, and any other aged male is also invisible. So I need to make a major point. The lifespan assumes that it is lifespan study of A-bomb survivors assumes that it is only looking at that gamma flash when the bombs went off in Hiroshima and Nagasaki in August of 1945. That one flash is the research question for the lifespan study. And that flash is much more similar to the X-ray, medical X-ray, which is the image on the left, than it is to the image on the right, taken by Robert Del Tredici as a photograph of plutonium in the lung. And all the black in that slide is dead cells from the very close radiation of the internalized radioactivity that's then continuing to emit inside the human body. Actually, this is an ape. So much closer to the Chernobyl, Hanford, Fukushima on the right side. Both, people get both, but we don't know if what I've told you just now applies to internal exposure. That's a question that hasn't been asked or answered. So I'm going to skip some of this. It has to do with we should have a life cycle that looks more like that because the differences are so great. We should understand that the female has its own somatic phase. But we want to move into talking a little bit about reference girl as I wrap up. It's only a first step. We need so much more radiation revision, revising of radiation standards than reference girl. It's a first step. But we want to engage in a process to invite input on what the parameters of a reference girl would be. How old is she? What is her weight? What's her height? What's her climate? Does race matter? If so, what is it? Culture, habits, and customs clearly matter. What else matters? We want to put together a discussion of this and come up with a draft and do some expert review of that draft. and then march her out with hopefully a whole posse to support her as a new proposal. And this is not a reference for girls. We want to propose her to be the new reference for everyone. So when a risk factor is given, it is for a reference girl, 1 in 100,000 reference girls. This will protect men and boys better, and we're happy about that. And it will protect girls at all. So just a quick run through on why. My teacher, Dr. Rosalie Bertel, is the one who sent me to the lifespan study. Her theory was that it has to do with more reproductive tissue in the female body. Other people have suggested that it has to do with a percentage of fat tissue. These are all the research questions. I'm going to skip to cell maturation or cell repair mechanisms. Is there a difference between males and females in that? And we now have a researcher who is proposing that it has to do with stem cell population. And that's very interesting. And we could unravel that at another moment. But we also need to ask and answer whether internal exposure also has a gender factor. And that is so important to know and understand for people living in contaminated areas. And finally, we need big research institutions to get involved. We need a new generation of researchers. It's not one field. It's not all left to health physics. It's epidemiology, cell biology, field ecology. Get big data involved, but they're not the same as a real data set with case control. And we need the epidemiologists to do that. And we need assessment of the practices in medicine. And finally, we need a whole lot of peer-reviewed publications to underpin a new policy debate. Thank you.